Hello everyone, welcome to Mindspan Education. Last video we were discussing about the central limit theorem. In this video we are going to start with a new chapter. But before we start with a new chapter, let me first of all bring some new terminology that will help us to go on further. If you recall from our last video, I have said it multiple times, and even in the problem we have given this statement that the random variable x1, x2, xn are taken or drawn from some distribution, some or same distribution. We have made the assumption that we are taking it from the same distribution. So what do you understand by this statement? So as per this statement, if we are taking these random variables from the same distribution, that means if we are taking it from the exponential distribution, that this random variable x1, x2, xn all will have the same distribution and they will have the exponential distribution. Whatever the from the distribution we are drawing, these will have the same distribution. And we have also made one more assumption while going through the central limit theorem, is that all these random variables are independent. Let me first of all bring some new terminology, and what I am going to do, I am going to restate this statement in that terminology. Then you will have a broader sense of this statement, that what exactly it means. So the first terminology is the population, and the second terminology is the sample. So what you can think of the population? So this population here I will relate with this distribution. So the population, you can think of it as a very large group, a big set of values or entities that we want to study, right? So the population will have some underlying distribution, but the distribution is unknown to us. Let me first of all take an example. So when we say the word population, the very first thing that come up in your mind is people, right? Like population of the country or the population of the world. But in statistics, population mean any full collection of item that you are interested in or that you are analyzing, right? It could be population of mosquito in city, it could be population of all the flowers in the world, it could be population of light bulbs produced in the factory, right? Anything. So if we are trying to estimate something about flowers, for example, then the population is all flowers possibly across our entire planet, right? Now obviously this population is so huge that we cannot possibly measure every item in it, right? We cannot go and check every flower or every mosquito. That is why we call it a population. It is so large, we only have the access of some part of it, right? And because it is so big, we don't know the exact distribution of the population. So what we do in order to study this population, we take a sample out of this population, from this population, right? Now when I say that take a sample, I mean this: we pick a few items from a large group that is a small subset, and we try to analyze this sample, right? And in mathematical term, taking a sample from population is same as saying that we are taking random variables x1, x2, xn from a distribution. So here this distribution is the distribution of the population, and this population is so big that it is impossible to go and analyze and draw a absolute distribution of this population. So what we do, we try to take a sample out of it, and this is what we are doing here also, right? We are taking n sample out of this distribution. right? So when I say that random variables are coming from some distribution, what I really mean that we are sampling from the population, right? And why do we call these random variables, why we call these samples random variable? Because each time we take a sample, we could get a different result, right? Let's suppose maybe we are studying about the flowers. Then first time you sample from this population, you do get a flower that have the height 10 centimeter tall, right? And next time you will again sample, maybe you will get a flower that will have the height 11 centimeter, and another time maybe it will have the height of 9.5 centimeter. Every time you sample, the value might change. That's the randomness, and we capture this variability by calling them random variable, right? So now we are in good position to connect everything. These random variables are nothing but samples. They are drawn from population which has some unknown distribution, and since we don't know the distribution, what we try to do, we try to estimate the property of the distribution using the sample. Now let's move further. And so since the underlying distribution of this population is not known to us, what we want to do is we want to estimate the mean of the population. Let's denote this mean as mu. So this mu is a mean of this population, and we do not have the information, or we do not know the underlying population of the underlying distribution of this population. So what we want to try is we want to estimate the mean of this population, right? That means we want to find the average height of all flowers, or maybe average income of a country, but we don't know, right? Because we cannot measure the whole population. So what we do, we take sample. So we define our sample as using this random variable x1, x2 and xn. So these are the value we got from the sample. Now what we do, in order to estimate this mean, that is the mean of the population, we compute the sample mean. So sample, what will be the sample mean? Sample mean, let's denote this as x bar, will be sum of all these sample divided by the number of sample that we have, right? So now this x bar become our estimate of the population mean, and let's call this as a true mean. Why? Because this is the mean that we want to estimate, and since we have involved here two mean, that is, one is the sample mean and one is the population mean, and we are calling it as a true mean because that is what we are trying to estimate using the sample mean. Now this sample mean gives us just one number. So you might have question that is this number always close to the true mean? The answer is not necessarily. If we take another sample, maybe on another day we take another sample, we might get slightly different sample mean, right? Depending upon the sample that we have taken. Or maybe on the third day you have again sample from the population, and it will be not guaranteed that on each day you will get the same sample, right? On the third day, whatever the sample you will get, you will have a different sample mean, right? So we might get slightly different sample mean, right? So we cannot fully trust on a single number. So here what we are trying to do is we are trying to do the point estimation. So instead of saying this mean with a point or with a number, what better we can do? The better we can do is we can give a range of this sample mean. So the range that we are talking about is our range of the sample mean, and this range may or may not capture the true mean, right? So let me first of all talk about this range. So before that, we have this sample mean, right? And this sample mean is a random variable, right? How? You can see that it is nothing but the average of the samples, right? So and these samples are itself a random variable, right? So you have this sample mean as a sum of the random variable, so definitely this will be also a random variable. So depending upon the sample that you have got, you will get, or sample mean will take a value, right? Maybe, so you understood that this sample mean is a random variable. Now this true mean will be a fixed value, right? This true mean exists for the whole population, but we don't know what it is. This quantity is unknown, and we are trying to estimate this true mean using some range or interval based on our sample, right? So instead of just giving a single number as an estimate, we are trying to give a range, and that will be more informative, right? So let me break down that. So that is what we are going to refer that range or that interval as a confidence interval. Now let me explain what exactly this confidence interval is. The interpretation of the confidence interval, let me first of all explain it by breaking down with this example. Let's suppose we have the population, and this population will have some underlying distribution, we don't know, right? And if it has some underlying distribution, it will have some properties like mean, expectation, mean, variance, expectation, all these things, right? And for this particular, what we are trying to estimate is the mean of this population, right? So so what you do, you go and on the very first day you take n number of random variables from this population. So these x1, x2, x3 and xn, and basically what are these random variables? These random variables are the samples, right? Then on the another day you go and take another sample from the same population, and then again on the third day you take another one. Now since we are randomly sampling, right? So this sample will be different, right? Population is big, and on the first day we have picked some sample, on the second day we will be randomly picking some sample. So we are randomly sampling, the sample will vary on each day, which means the sample mean will vary, and so the range or the interval that we calculate from this will also vary, right? And this interval might capture the true mean or it not might, right? So on the first day you have got this sample and you have calculated some range of the sample mean, and you have got this, and within this true mean has been got captured, and another day you got some other interval based on this sample, and this might not capture the true mean, and another day you got and you try to find this interval, and this interval is capturing the true mean, right? And let's suppose you do for this 100 days, that means you will have 100 sample. So each time we calculate the interval based on these sample. So we calculate the interval of sample mean based on this sample. Now suppose that out of those 100 intervals, 95 of them contains the true mean and 5 of them don't contain it. So this is the idea behind 95% confidence level. But of course, in practice, you cannot go and sampling 100 times or 1000 times from the huge population. It is not practical. So here comes the idea of the confidence interval. In reality, you usually just have one sample, right? From the very first day, you will take that one sample and do some calculation. And how we will do some calculation, we will go through that. So you take that sample and you do some calculation based on it, and out of that calculation you get a range, a confidence interval. Suppose you calculate a 95% confidence interval from that one sample, right? What does it mean by 95% confidence interval? It means that if you had done the whole sampling process 100 times, then 95 of those interval would contain the true mean. So this is what the 95% confidence interval. So you are not saying this, that the particular interval has a 95% chance of containing the true mean. No, the true mean is fixed. It is either inside the interval or not. But what you are saying is that the method you use to calculate this interval is reliable. It gives the right result 95% of the time in the long run, right? So here where people go wrong, a lot of say that I am 95% confident that the true mean lies within this interval. This is wrong interpretation. You are not expressing the confidence about the true mean. The true mean doesn't change. You are expressing the confidence in the method and the process used to create the interval from your sample. The interval is not a fixed thing. It depends on the sample mean, which depends on your sample. So once the interval is calculated, it either contains the true mean or it doesn't. There is no 95% probability anymore, right? So the 95% refers the process, not the specific interval. I hope this makes clear. So now let's try to define the confidence interval formally, right? And I think you have got the interpretation of the confidence interval. So we are talking about this interval, right? the interval that we built around the sample mean. Now if you look at the upper bound and the lower bound of this interval, these are actually the random variables, right? Because they depend on the sample. Depending upon what data you get in your sample, the sample mean will change, and so the upper and lower bound will also change. So both the ends of the interval vary from sample to sample. Right? Now what does this probability mean? So let me first of all clear here that this alpha, if I am talking about the 95% interval, then this alpha will be 5% or 0.05, or if I am talking about the 99% interval, then this alpha will be 1% and 1 minus alpha will be 99%. Right? Now coming to this probability. So what does this probability mean? What kind of belief or interpretation we should take from it? So here is the idea. If you were to take 100 different samples from the population, and for each sample you calculated the confidence interval using the same method, then about 95 of those interval would include the true mean, and that is what this 95% probability is talking about. So if we take this alpha is as a 5%, then this will be 95%, and this probability is at least 95%. So what this it is saying to you, that if you would had taken the 100 samples out of, and you had calculated for each sample, you have calculated the intervals, right? And this calculation is telling you that out of those 100 calculated interval, 95 of those interval are capturing the true mean, right? So this is the interpretation you should carry. The confidence is not about the true mean being in the interval you just calculated. It is about the reliability of the method you use to calculate the interval. The method will capture the true mean about 95% of the time if you repeat the sampling process. Alright, let's go ahead and see how to construct a 95% confidence interval.